Welcome to this video. Here I'll be finishing this 1969 BC calculus multiple choice problems. Okay, we left off on number 30, so let's dive right in. Okay, so this series, -1 to the n, x to the n over n factorial, is the Taylor series about 0 for which of the following functions. Okay, so you already start eliminating some of the choices because if you follow my recommendation, you should memorize the Taylor series for sine, cosine, and e. Okay? Sine is just the odd powers. That's how I remember it. This is not just the odd powers, so we can eliminate that. Okay? Cosine is just the even powers, so we can eliminate that. E to the x does not alternate sign like this does, so eliminate that. So we are left with two choices. This looks very close to e to the x, though. It's just this -1 to the n power that's throwing you off, probably. Is it e to the negative x? So e to the x, once again, I wrote what the Taylor series for that is. It's just x to the n over n factorial. E to the negative x, you just plug in, where there's an x, you plug in negative x. Excuse me. So negative x to the n over n factorial. We can break this up into -1 to the n x to the n over n factorial. Okay? Because this is -1 times x inside the parentheses, so you can break it up like this. Okay? And this matches exactly that. So answer is D. Okay? This was in the AB, so look at that video. This one for sure is BC because it's talking about series converging. For what value of x does this series converge? They even give you the general term n to the x. So another way to write this is, where do I have it? Is summation as n goes to 1 to infinity, n to the x. We start from 1 because they give us the first term as 1. Okay? We can rewrite this as summation as n goes from 1 to infinity, n to the negative x power. Why do we want to write it like this? By the way, this is the same thing. Hopefully you can see that. Why do we want to write it like this? Well, we want it to look like a p series. P series looks like 1 over n to the p, right? And we know when a p series converges. P has to be greater than 1 for it to converge. Okay? So here, instead of p, we have negative x. So we need negative x to be greater than 1 for it to converge. We solve for x, it's not just negative x. So x is, remember, when you multiply by or divide by a negative number, you have to flip the sign of the inequality. So x is less than -1. That's the answer for this. Okay. Let me confirm one more time with the key that that is the answer. 32B, yes. Okay, this one, I did it in the AB video. Average value, very easy. It's 1 over the interval, integral from the endpoints of the interval of the function. As simple as that. Okay. This one I've done in the AB video. The trick here was this. It talks about intersecting at right angles. So instead of the tangent line, you want to find the negative reciprocal of the derivative, okay? Which derivative is the tangent line. So you want to be negative reciprocal for it to be perpendicular or right angle. So negative reciprocal would be x squared, and then you integrate that will be d if I remember correctly. Okay. This one again is in the AB. They give you acceleration. You want to find v of t first, and they give you the initial condition that the initial velocity is 0. So you can find v of t exactly, not a general solution. You can find a particular solution, and then you integrate from 0 to 2 of the velocity to get the distance traveled. Okay. This one, again, is in the AB. This is just using the tangent line. This linear approximation. Use the tangent line to approximate a nearby point. This, it even says in the key that this is not covered in AP Calc anywhere. This is the epsilon delta definition of the limit. Okay, so I'm not going to go over this. this one, f of x is x squared plus 1 to the 2 minus 3x, then f prime of 1 is, here we need to use logarithmic differentiation, okay? It's from x to the x power, okay? So we call this y instead. So we log both sides. So ln y is ln of this guy, okay? So I wrote that here. We use properties of log, so we pull the power outside the log. So 2 minus 3x times ln of x squared plus 1. That's ln y, okay? So now we differentiate both sides of here and here with respect to x. So 1 over y dy dx equal to, here we need product rule. First d second plus second d first. So first d second, here we need chain rule. Derivative of log is 1 over the argument, which is x squared plus 1, times derivative inside, that's 2x. And then plus second d first, so second here, d first, derivative of this guy is negative 3. Okay? So I just started plugging in numbers to make my life easier, to simplify stuff. So they give us, we want f prime of 1. So when x is 1, what's f of 1? What's the y value in the original function? Okay, so we just plug in 1 over here. So it'll be 1 squared plus 1 to the 2 minus 3 times 1 power. That's just 2 to negative 1, which is half. Excuse me. Okay, so we plug in 1 comma half into here. So y is half, I plug that in. And then wherever there's an x, I plugged in 1. Okay, so 2 minus 3 times 1, that's 2 minus 3, which is negative 1. Here it's 1 over 1 plus 1, which is half. 2 times 1 is 2. ln of 1 squared plus 1, that's just ln 2. And then we have that negative 3. So this we can change to 2 d by dx. Over here, this half and this 2 would cancel to 1, so we are left with negative 1 there. And here we have minus 3 ln 2. So dy dx is negative half, so divide both sides by 2. Negative half minus 3 halves ln 2. Okay? Or you can, multiply by it. So here I just factored out the half, because I probably did not get, none of those match that, so I got to do some algebra. Okay? So here I factored out a half from both terms. Okay, so negative half even. So on the inside is 1 plus 3 ln 2. Okay? It looks like by the choices, we want to combine it into one log. So 1 we can change back to ln e. It's the same thing. So it's ln e plus 3 ln 2. These we can use properties of logs to combine. Oh, but before that, we can move this back inside the log as an exponent. So ln of 2 cubed, which is ln 8. This is ln 8, okay? And then we combine these two, becomes ln of 8e. Again, just all properties of logs, okay? So it becomes negative half ln of 8e. That's choice A. Okay? Here, this is a chain rule. I did it in the AB video. Okay? This one is an AB video. I made a substitution. U is 1 minus x. If I remember correctly, it's for all n. It becomes the exact same thing. Here, again, AB video. Go look there for the worked out solution. I believe I just broke the integral up from minus 1 to 2 is of this curve, and then from 2 to 3 of this curve. Okay? 42, x squared cosine x is f of x minus integral 2x sine x dx. Then f of x is this on the left-hand side. You should be able to recognize as integration by parts. Okay? So I did that over here. Okay? We choose a u as x squared, du is 2x dx then. We choose our dv to be whatever is remaining, which is cosine x dx. V, we just integrate, that's just sine x, okay? So it's uv minus v du. X squared sine x, that's uv, minus v du, that's 2x sine x dx, okay? So that's exactly what we get over here, okay? This matches this. So f of x is just x squared sine x plus some c. Okay. which of the following interval gives the length of the graph of y is tangent x between x is a and x is b, where a less than b, 0 less than a less than b less than pi over 2. They give this interval because we know that tangent is undefined at pi over 2. Okay, so how do we do this? You just need to remember the arc length formula, which is, I did not write it here, but the arc length is what, integral from a to b square root of 1 plus dy dx squared, or dx dy, doesn't matter. Okay, or for parametric, even dy dt dx plus dx dt's. Okay, hopefully you remember all that. Okay, so we want this. So we want to find dy dx. If y is tangent x, dy dx is secant squared x. Okay, so 1 plus dy dx squared, not quantity squared. 1 plus dy dx squared. Okay, so it'll be 1 plus secant squared, which is 1 plus secant to the 4th, okay? So arc length would be integral from a to b, square root of 1 plus secant to the 4th dx. That looks like this one. Okay? Okay, we have 2 more problems. Excuse me. Okay, this, I don't think this is covered in BC calculus anymore. This is differential equations regarding second derivatives and all that, okay? But I'll still solve it because I know how to solve this readily. If f double prime x minus f prime x minus 2, f of x is 0, f prime of 0 is negative 2, f of 0 is 2, then f of 1 is what, okay? So this is a second order differential equation, okay? Instead of f, you can think of it as y double prime minus y prime minus 2y is equal to 0, okay? So the method to solve that is we have a characteristic equation. So instead of f and f prime and f double prime, you can write it as r squared minus r minus 2 is equal to 0, okay? So we can factor this as r minus 2, r plus 1 is 0. So our solutions are negative 1 and 2, okay? So if you learned this, again, I don't think the teacher's in BC anymore, but you know that the solutions to this type of problem is exponents, e's, okay? So the general solution is c1 e to the negative x plus c2 e to 2x. That's where the r's come in over there, okay? And since the second order equation, they need to give us 2 initial conditions, okay? So that's why they give us 2, okay? This is our general solution for f. Our general solution for f prime, we just differentiate f. It'll be minus c1 e to negative x plus c2 e to 2x, okay? We plug in our initial condition. We use our initial conditions, okay? So f of 0 is 2. We plug in x as 0. We get c1 plus c2. F prime of 0 is negative 2. So we plug in x as 0. We get negative c1 plus 2c2, okay? So this is 2 equations, 2 unknowns. We can solve the system equation, okay? So I just add these 2 equations together. 2 minus 2 is c1 minus c1 is 0. So c2 plus 2c2 remain. So 0 is equal to 3c2 after I simplified. So c2 is equal to 0, okay? And to find c1, you can just plug into either one. This one's the easiest probably. c1 is equal to 2 then. Okay, so our general solution is f of x is e to the negative 2x. We just plug in c1 and c2 into here. c2 is 0, so that goes away. c1 is 2, so it's 2e to the negative x. So we're interested in f of 1. That's what the question asks us. So f of 1 is 2e to the negative 1. That's choice E. Okay. Once again, I don't think they ask this on BC anymore, or they don't teach this in BC anymore, but double check. Okay. This was not hard to solve at all. Complete interval of convergence of the series. The sky is, okay. The technique that you usually use is the ratio test. So let's do the ratio test here. Okay. This is the original series. If this guy is a sub n, the ratio test is limit as n goes to infinity, a sub n plus 1 over a sub n. So wherever there's n, we plug in n plus 1, and then we multiply by the reciprocal. Okay, that's the ratio test. So we simplify this x plus 1 to n plus 1 divided by x plus 1 to n. Use properties of exponents, you're left with x plus 1. Here, we just leave alone. Okay? X plus 1 does not depend on n. We can pull it out of the limit. Keep the absolute value sign. Okay, then we're left with this. Okay? Here, how do we evaluate this limit? The easy way is, it's a horizontal asymptote. You can think of it as degree test. They're the same because when you expand this out, it'll be n squared. That's the biggest degree. Since they're the same, you take the ratio of the leading coefficients, which is both 1. So 1 over 1 is 1. So that's the limit, 1. So x plus 1 in the absolute values times 1. So that's equal to x plus absolute value x plus 1. Okay? Ratio test says that this guy has to be less than 1 in order for it to converge. So let's solve this inequality. X plus 1 has to be less than 1, but also greater than negative 1. Remember, that's how we solve absolute values. So x has to be greater than negative 2, but less than 0. But remember, the ratio test is inconclusive when it's equal to 1, which is at these two endpoints, so we have to check the endpoints. When x is negative 2, we just plug in x is negative 2 here, we would get what? Negative 1 to the n over n squared. We know this is a convergent series because if we used alternating series test, this would converge, okay? And when x is 0, that's the other endpoint, we plug in 0 over here. We get 1 to the n over n squared. This is a p-series. That's p with p equals 2. So we know that that's convergent. So both the endpoints are convergent. So the interval of convergence is from negative 2 to 0, both inclusive. Okay? And that is choice E. Okay? So this is for sure a BC topic, okay? And that's it for this exam. So this was a shorter video, which is good. Hopefully it was helpful. Please give this video a like if you did find it helpful, and please subscribe to the channel to look out for more practice exams, me solving practice exams.